Right, so this is a continuation from last time. So we reviewed, I want to say, 2/3 of this last time. And so today we just walk the remainder of that. Hopefully it doesn't take us 2 hours. It would be good.
Yeah.
I have to be honest, I kind of lost the train of thought. Just look at the notes from last time. So I think yeah, so there was one follow-up from you, Tanner. It's like then I will see whether they are just applying a pattern or new APIs, in which case we'll take another look.
Right, and so the first few here are just the same pattern. So min number pairwise, and min number across, and then min pairwise and min across are all equivalent to the max numbers that we've already reviewed and approved, just for min instead of max. And then use multiply add is similar to the use multiply. No, we've not reviewed use multiply add yet. That was one we needed to. And then multiply extend, we need to review the reciprocal estimates. I don't think any progress was made on those. We're going to move them to a separate issue, and then reverse element bits needs to be reviewed.
Right, so then min number and min number pairwise. I think we already had comments on that one that we wanted some different naming, I think, on those, right?
For which ones?
Oh, never mind. We have already done that. Nope, never mind. Misremember what I was saying. So then min number pairwise, I guess if it's the same pattern, should be good to go, right?
That's my belief.
Min number across seems fine. Min number pairwise is fine. So the 64 versions are already there, right?
Where applicable, yes.
With this min pairwise or max pairwise didn't have longer.
They do on the 64-bit versions, correct?
No, the 64-bit versions don't have long view long.
So there's no, I guess, because max pairwise long string.
Right, because with
like just
with the
classic.
there's no scalar version for them effectively.
Okay. This is just max.
Yes.
Took me a minute to come to that conclusion. You don't need a complicated instruction, but a simple one.
That seems unproblematic.
Across is the last thing that we did. It's the word max with min.
Should be the same.
And the return types are vector, not scalars.
Let me fix it. And they're all 64 except for the, well, either 64 or 128, right?
No, they're all for the record.
They're all?
Yes, because they return scalar one. Max across has vector 64 of E always as a return type. And vector 128 as
Right. It's returning a scalar result, but it returns it in a vector register, and so we have to return it also in a vector register,
Makes
or a
sense.
vector type rather.
And they're all 64, even the 128 versions. It's all in the same register. Yes. Right.
Yes.
Then find, multiply, add, fuse, multiply, add.
I think we're to new concepts.
Yeah.
We decided we don't like ACK, we like accumulator. Is that right? Or let me look.
We went with add-in.
Oh wow, we actually did call them add in the minuend.
Yeah,
because it was the be a weird different word was really all we were going for.
Yep, add and left and right, right? That's what we said. Yep, that works.
We already.
Yeah.
Oh,
we
absolutely.
reviewed multiply, add, and subtract.
Yes.
Which are the integer equivalents, and they are not a fused operation because that has no concept.
Right. Okay.
And then the ones that take float as the third parameter, we name those by selected scalar, taking a vector and a byte right index.
Yes.
Sorry, now I'm confused.
It's a different method.
Yeah. It's similar to something we reviewed already, which is multiply, subtract, but it's slightly different in that it's a fused operation because it operates over floating point values.
Yes, I think the fused multiply add here, assuming you call that add-in, makes sense and fits the pattern we already established.
And so we're good with the names for the parameters?
Because your formula shows it's for each MS.
Yeah. Sorry, what was it?
Says we need an image.
So we are good with left and right.
Yeah, left and right.
The left sub thingy, or left sub element times the right constant plus the accumulator sub. So I think that left and right is what we did.
Yep.
I mean, in the other APIs, right is a vector, but it's the same concept, so good enough.
Good to me.
Yeah.
And for these in the other APIs, we call them minuend. No, it's our treasury section.
What?
Example we did.
Someone on Twitter is going to flame.
So when the formula is right, it is a minuend.
All right.
Wins. I don't think we've pluralized it.
Menus and
All right.
I think so, because there's no space in the word.
And Task10 will win the prize for most methods added to the BCL.
yeah, have we considered size on disk?
I think we
I
have.
believe we've looked at it, and we weren't too concerned. Since most of all of the ones that exist for a non-supported platform, they compile down to the same method body definition, since they're all just throw platform not supported exception. Anything for the current platform is recursive, and so they'll all have different method bodies, but I don't think we've had any for that yet.
The ones that have the same method body, the compiler folds them into the same method def?
Yes.
Why is multiply extend not just called multiply? Did we use extend as a previous suffix somewhere? We did. Wait. Oh, never mind.
So Jared was asking. Oh, okay, that was already answering that.
Jared asked why we aren't passing by in, and the reason is because it's vector code. Passing by in is less efficient since it means it's address taken. All of these are functionally in line to a single instruction, and so functionally they are handled by value, not by reference.
I was about to say, like, the argument really is because they're intrinsics, the semantics are basically you put the thing in a register, right? So it is effectively loading by value, yeah.
So which one are we on now? Multiply extend. So for SSE, we call this instruction simply multiply, and I assume it's the thing. Take each element from the left, multiply by each. Right? Why did you recommend we extend something?
That's the name given by the actual instruction in this case. It also has special handling for if one value is 0 and the other value is infinite. In particular, it returns 2.
What? Say this one more time, please.
0 times infinity is 2.
Yep. This multiplies floating point values in the vectors of two source SIMD registers. The resulting floating point value in a vector and writes the vector to the destination. If one value is 0 and the other is infinite, the result is 2.0.
I mean, as a math major, I can say, once you combine, or once you put infinity in a formula, you are allowed to choose whatever is convenient as the answer.
Wasn't it like,
Oh yeah.
Multiply extended by selected scalar.
anyway, so, all right.
Did you get the note that the one that didn't need signature change, the method group is multiply extended?
Which one?
So we fixed the one that was missing the last parameter to be multiply extended by selected scalar.
Yeah, so the previous one I also named multiply extended.
Okay, perfect.
Yeah.
That was the
And then the vector, so on the right hand side we still say byte, right? It's not vector, right?
It's right.
It's vector byte.
Yeah. Good. All right.
And I didn't.
And matching the size of left is correct.
Okay.
Yep.
And if did we previously talk about a multiply extended? Because searching for multiply extend, I see it at various places, and the PRs or the issue's too big for me to tell what's in which state. So
it's because the entire API proposal is now duplicated in this issue like 4 times.
Okay.
You're welcome.
Just making sure that we didn't need to go fix a thing that we had already figured.
Yeah.
Oh, we were looking at the 64 bits. That's what's. It's like, I swear we reviewed some of these already.
Yeah, I have to say, like, GitHub is not really great when you don't have a code editor where you can fold stuff.
We had a review.
Yeah, see, there is that.
Do you? I guess yeah. Vector 64 double doesn't. You know. That was Jeremy's also.
Also, Tana somehow managed to fuck up the indentation, so some parts are off by 1 space.
The white space is significant. It tells us what's already been reviewed.
Something is. This is horrible. I also think I have a brace mismatch now. Congratulations. Anything works here. Anyway, so reciprocal estimate. You good with that?
Yeah, we've already approved reciprocal estimate for other types.
Yeah, but we said for the step versions, which I don't think it's called out at the top, that needed more investigation as to what right was.
Yeah.
That's the comment, should the arguments be something more specific than left and right?
Yes. The comment just says C box.
Right, because they shouldn't be taking a index, I think, was the other bit.
But we also have outstanding.
Yeah.
Figure
check
out what to do for reciprocal.
Yeah.
So, yeah.
Then the square root estimate, I think we talked about this as well last time.
Yep, that's what we called it for the other
The shape is also correct.
values.
The overload here is,
Yeah, I was about to say.
and that is deferred for the with all the other steps.
Yeah.
So what is it? Reciprocal square root step estimate, or
Drop
also don't
estimate.
put index here.
Drop the word estimate.
Oh, it's just
But the
reciprocal
signature's
square
wrong
root step.
anyway.
I see. And the signature is this thing we still have to figure out, right?
Yeah.
That works for me. And then reverse. The only other thing that you.
So I think we approved previously reverse element bytes. This is different because
So for I did figure out what the left and right are. So it doesn't necessarily matter which is which, but in this case, the typical usage is left is the thing you're getting the reciprocal for. So if you wanted 1/17, 17 would be the left, and then the right-hand side is essentially the changes based on which iteration you're on.
so you take the output and put it as right on the next step.
Yeah, so let me just screenshot this. Here's an example of Newton's method for computing the reciprocal and how the algorithm would functionally be used.
Okay.
And oh my god, can I not project this?
No, it's okay. It's yeah. So the left would be the value you're trying to get the reciprocal for, and the right would be the accumulator, effectively.
Well, it doesn't necessarily matter since multiplication is commutative, but right. One's basically the value you're computing the reciprocal for, and the other one is a value that depends on which step in the series you're doing.
Current best guess.
Current best guess, yeah. It's quite a parameter now.
That's what Newton's method is.
So I think left and right might be the best, and we would just need to document that this is doing effectively 2 minus x time 2 minus left times right.
I mean, that seems fine.
Okay.
So then the signatures are correct then, basically? Is that the conclusion?
Yeah, other than the byte index.
Drop that parameter.
Okay, so we drop the byte index.
Vector or vector? Scalar.
Yeah, it's vector vector.
And then, okay, so then reverse element bits. Before we had reverse element bytes, is that what you said, Levi?
Yes, and this R bit, which this is hard to find, reverses bits in a keyword. Oh, wait. Is there a version of R bit that works on 8-bit elements?
Well, R bit works on byte. It's 8-bit element technically.
Have the RAV versions, the different OpenLoop RAV versions that work on different data sizes.
So R bit works on 8 bits. RAV 16.
I'm just misinterpreting the documentation.
I only see one that's a 32-bit and 64-bit variant.
Yeah, because when we looked at reverse bytes, the width of each element was passed in as a constant to the instruction, but I don't see any such parameter here, which is what's thrown me off.
I see the thing. I was looking at the scalar version, not the vector version.
We also said last time it needs more work or clarity. I'm also not sure what we meant.
No, that was reverse element bytes, which is different.
So there is a vectorized R bit?
Yes.
Oh, R bit vector, there it is.
Yeah.
Right.
Okay. So yes, there's an 8-bit. No. The arrangement specifier, is that bits or bytes? It says 8B or 6B.
It's 8 elements of byte size.
Okay, so 64 or 100.
Yeah. So these signatures should be correct.
Yeah, okay, yep. It's curious because I'm reading, like looking through ARM's developer manual, it just says reads each vector element from the source register, reverses the bits of the element, and then writes it to the destination. But it doesn't actually say how wide an element is anywhere in the doc, as far as I can tell.
If you look for the decode for this encoding, it has integer e size equals 8.
Okay. So it's not just enough to read the docs, I actually have to go look at how it's encoded.
Yep.
Okay. Thank you.
Right, and I think we can consider this one done, right?
Yeah.
So I just pasted in the entire API surface now, so we have one comment that has everything in there, not just the half that we did today. I think we already approved it last time for the half that we had, so that should be good. Right, let's close this one then. Shift and Permute intrinsics. Oh yes.
Oh, is this the one with the fun names, Tanner?
No, that's the next one.
Oh boy, we never run out of fun things. All right.
vectorized?
The vectorized and the scalar version are the same instruction page. You just have to scroll down a little bit to see the scalar encoding.
Don't we normally make things like shift parameters bytes when they're immediates, assuming I'm reading this correctly, that that's an immediate?
I think it depends on how big the allowed immediate is. In this case, it is only a byte, so it should likely be a byte.
Yeah, the valid values are 0 to 60.
Yeah, so what this does is it left shifts the left element at a shift amount, and then it takes the second operand, knots it with the mask, and then does it with the shifted result.
Specified by the.
Yeah, that is where it is mask. Mask is a series of 1 bits based on the size, and then left shifted by the shift amount.
Nice diagram.
So the mask is a fixed value for the.
Yes. Well, no, it depends on what the shift amount was. So I just pasted the code in.
So I do think the first few values probably need to be a vector as well, because it's a scale operation on the CMD side.
Okay.
You probably should rename it by scalar or something.
Since it's only taking in scalars and operating on scalars, that is the lowest element. I think we just postfix it with scalar, which is different from the multiply ones, which were taking a vector that wasn't the 0th element.
Oh, right.
And then in the context of here, LSL is left shift logical.
Oh,
Yeah, there's actually a diagram here that I missed.
what page is the diagram on?
1477 in the particular copy of the manual I have. Here we go.
You could correct that.
I think I'm looking at the wrong manual.
Well, there's like there's a B copy and a D copy, and then there's another copy. Depending on whether you want the additional instructions for like ARMV 8.2, 8.3, and 8.4.
Tanner just posted a item to the Teams.
Yeah.
You think I can project this, right?
Can you also send us, Tanner, a link to the exact manual that you're looking at?
Yeah,
No, because I don't have it, and I had to like create an account and log in to get it.
Oh, okay. Because I found one on ARM's website that doesn't have any pretty diagrams.
You don't have to log in to get it anymore. I think you probably went to the old site.
Okay.
So this is the link that should have one. You can also just get the XML inputs as well. That's easier to look at than your giant PDF.
Perfect, thank you.
Apparently. All right, so you happy with that?
I think we just need to change it to be vector, like Tamar had said, but otherwise it looks good.
Which vector type do you want? Vector 64 or 128?
Yeah, 64, I believe.
And that's both the return type as well as the argument types? Okay.
So there is an SLI scalar. How does that work? Is that really using vectors under the covers on?
That's what it appears to do based on the encoding here.
Okay.
The shift remains as uint?
Yeah,
Byte.
Yeah. All right.
And what's the behavior if someone passes in a non-immediate for that? Do we fail at runtime or what?
So what we do for x86 is there's a fallback mechanism where it no longer inlines, but the method body for the actual call ends up being a jump table.
So that means we're basic. I wonder if we actually need some analyzer or something that will warn you when that's about to happen.
Add it to the list.
Basically saying, like, you think you're about to call this very specific instruction, but in reality, you're making a call to a jump table that sits in front of this instruction.
Possibly. The other issue. Go ahead, Carol.
I would just suggest that's something we should consider. Not specific to this. It's much broader issue than this particular case.
Well, I was going to say the behavior you get might also depend on what optimizations the JIT happens to decide to do.
Sure.
Like if you're going across two method calls, there's some known issues where it might not be treated as a constant and you might get a call in certain cases, but in other cases it will propagate the constant down.
Encouraging this answer, but could we consider exploding this into left shift and insert 0 through left shift and insert 31 or 32 or whatever the maximum?
I don't think so.
Okay.
We've got lots of other cases on x86 where this already happens, and those have up to 256 scenarios.
That's fair. Asked and answered. I just.
Doesn't it seem like this is something the C# compiler, the C# language could accept some kind of attribute on the parameter that says this must be a constant in this range?
I actually just like strawman that in chat that we can.
There was a proposal for that, and it was determined this was a very niche scenario, and it wasn't worthwhile for broader language support.
Yeah. But we could do it as an analyzer, though, because we have more flexibility. Okay, sounds good. Right shift and insert. Arithmetic or logical? I guess the first one is arithmetic and the second one's logical? Or did I just make everything really hard?
Left shifting
the
usually
the
logical.
Actually, shouldn't
operation
matter.
says
Logical.
the operation says logical shift right.
Yeah, but you're retaining the high bits of left, correct? So I guess it shouldn't matter in the end. Because when you do left shift, you retain the low bits of left. So when you do right shift, presumably you retain the high bits. Does that sound right?
When you do left shift, you insert the low bit of right. Because of the insert. So you shift the left and
Sure.
and then you insert the low bits of right to fill.
But you're not. I guess what I'm trying to say is like you're not bringing in 0 bits as part of the first method group, because you're replacing what would have been the 0 bits with some other data.
Right. Mm-hmm.
So here I guess would be you're replacing what would have been the high bits with some other data. So arithmetic versus logical should be matched. Okay.
Well, it does somewhat in that if it was arithmetic, then ORing would keep ones if the most significant element was 1, because you OR the result from right. So it is functionally a logical right shift, and then ORing right for the upper bits.
So then we are good with the name as is, or do we want to change?
It might make it more clear if we called it right shift logical or logical right shift.
I think that would be good.
So preferences for logical versus right logical? I would probably go with right logical because it seems a bit more symmetric. If that makes sense.
We did shift right logical and shift right arithmetic in x86.
How does ARM call it?
ARM is shift right rather than, ARM is also shift right. That's what the SRI is. Shift right I immediate.
Shift right insert.
Yeah, shift right and insert, sorry. So maybe we should just call the top one shift left logical and the bottom shift right logical.
We need the word insert in there somewhere.
Right, and insert. Sorry.
Yeah. So shift left logical and insert, shift right logical and insert.
Yeah, I think that would be my vote, just to make it clear. And since that's the naming we went with x86, and it matches the instruction naming other than the logical bit.
Well, if you think about this, boring. And so those are the names then. Left. And signatures. This insertion doesn't matter.
That looks right to me if everyone else agrees.
I can go either way on whether or not we need the logical. The instruction's complicated enough that no one can stumble upon it. They're going to have to look at what it does.
Yeah, I don't think we need logical.
I'm okay with it being there.
Yeah, what are you said you think it would be good to have it there?
You know, I would have it there on the shift right, but I don't feel strongly.
Yeah, I mean, I kind of agree with Jeremy that it already looks complicated enough that you're not likely to call it accidentally. But like, yeah, I also don't have strong feelings one way or the other.
It might also be a case of consistency when we start looking at the others, because there are more forms of shifting that exist. Like there's a signed integer shift right and accumulate immediate. So it might become a case of just for consistency, it makes it clearer in the context of everything else.
Yeah. Yeah, I'm okay with that.
So you're saying leave the word logical? All right,
yeah.
Keep the word logical?
Yeah.
So
yeah, because I think it makes it clear for this specific case, at least on shift right. And then when we look at everything else, I think that might help disambiguate as well.
Yeah, works for me. All right. So let's do that. Okay, let me leave it as
Very distinguished.
just seems unnecessarily complex.
Maybe in the specific it's complex, but in the abstract or in the whole it will be simpler. I'm gonna trust Tanner's assertion on that.
Right, then let's scroll. I can't believe I'm saying that. Left shift and insert. I suppose everything where it says U in shift, it really should say byte.
Yep.
And then
And just confirming, the SRI and SRI are the same operation, just they're encoded differently in the different assembly?
Yeah, for ARM32.
Okay. So the 64 one is still a vector operation, it just doesn't use the V prefix.
and we probably should want to rename it to shift left and insert, I suppose. Probably shift left logical and insert then.
Yeah.
And the fact that 128 has support for U-long is correct, right?
Sorry, could you repeat that?
It has support for U-long and long, I suppose that's correct. Because the last times.
Yeah, there's 2G.
Because the other two were in base.
Okay. Well, anybody?
I was going to ask Tamar, is the vector 64 long and U-long supposed to be in base?
For the scalar version?
Yeah. Because I was looking at the operation for all encodings, and it doesn't have a different one for scalar form.
The scalar one, it says only has on D. It only supports a 64-bit value.
Right, but it's under base. It's under ARM base right now, not advanced MD.
So it has to be moved into advanced MD.
Okay, that's what I thought.
So should it be advanced SIMD or advanced SIMD ARM64?
I don't see a restriction on it being. It says it supports size equals 64. The SRI. Elements equals 1. Yeah.
I think someone asked if it should be under advanced SIMD or advanced SIMD 64.
Mm-hmm.
It should be under 64 because the AS32 doesn't have a scalar version.
It doesn't have scalar, but the decoding doesn't seem to say that for the 64-bit vector variant that E size 64 is invalid.
Right.
Right. So that means that vector 64 long would be valid and applicable on ARM32.
Yeah, I guess you could reuse the register. Yeah.
Are you sure the 64-bit SIMD vector supports 64-bit element size?
As far as I can tell from the decoding here.
Yeah, you're right. It says that it has a size 64.
Should we take this offline or should we move on?
We can probably follow up a little bit more offline, but the question is just whether it moves to advanced SIMD or advanced SIMD A64 for the vector 64 U-long versions.
Yeah, from an API review standpoint, I think it's fine either way. It's just whatever is correct, right? Like,
Right.
so what should I write some stuff up? Should I say
Just confirm that it's supported on both arms.
confirm which overload are we talking about? The
Scalar version.
what is the scalar version? I mean, we
The
changed
version
it,
above that we just talked about first.
but we changed them
Yeah.
also to take vectors, right?
Right. So those ones have to be under advanced SIMD. The question is, should they be under advanced SIMD directly or advanced SIMD.ARM64?
I see.
And so we just need to follow up and determine which one it is.
So should we also add suffix scalar?
Yeah, that would be the other bit.
The ones we already talked about are now shift left logical and insert scalar. But then the method group we were looking at doesn't get the word scalar? Or does it?
So the one in ARM base should get the word scalar, and the others shouldn't.
Okay.
So the advanced SIMD should
I guess put scalar on the ones that need the word scalar, and let's move on.
And we'll figure out.
right. The one advanced SIMD, we just only renamed them to the naming convention except for the scalar part. And I changed the shift to be byte size.
Yeah.
Then I guess for the right one, it will be the same thing. So we would call this shift right and insert.
Yeah.
And then again, when shift would be byte. All right. Extract and narrow low.
Yeah, so this reads each vector element, narrows each value to half the original width, places the result into a vector and writes it to the lower or upper half of the destination. So that would be the low and the high.
The low and the high supposed to have a different number of parameters?
Yes, because in the case of low, it clears the upper half, while in the case of high, it writes the upper half without affecting the other bits. So effectively, you would do low, and then you would use the result of that as the accumulator in the high operand. The high operation.
So the accumulator is just something you're going to splat into the resulting value.
Right. I think in x86 we called that lower, rather than accumulator.
Did we have an x86 variant of this?
No, but there was things like load high and load low, where it would load a value into the lower or upper half of the result, and it would take the existing value for the lower or upper half, and we called that lower and upper in that case.
Okay, no, I see that. We should probably do the same thing here then, say lower in value.
Yeah.
Because the lower part of the lower is maintained, right? And the upper part of the lower is thrown out.
Okay. Unzip even.
Is this?
Oh, it unzips. Even.
There's a nice diagram.
Why does the instruction ending in 1 work on even and on 2? Sorry.
So that it maintains odd parity.
Ooh. What does this do?
Do this.
So it reads the corresponding even-numbered elements from 2 source registers starting at 0, places the result from the first source into consecutive elements in the lower half of a vector, and the result from the second source register into consecutive elements of the upper, and then writes it to the So I don't think Immo has it. I will copy and paste the diagram again. Okay.
I just want to make my life miserable. I see.
I think we call these
Okay.
unpack low and unpack high on x86. I think that's the equivalent.
I agree, though. Unzip seems like an appropriate name for this operation.
I think they
Yeah.
had slightly different behavior though than unpack low and unpack high.
That might be the case.
Because I think unpack high works on the high elements of both input vectors, whereas this is working on simply odd and even rather than all high or all low.
Yeah, and unpack also does interleaving.
Yes. Because we use unpack for widening.
Yeah.
And that would not. Yeah, unzip seems.
All right. And then I guess the same changes for unzip odd.
Have zip low and zip high, so the method name is clearer than the parameter names in what you're trying to do. Zipping off, so that might be in the end.
Yeah.
because I know that like on the Intel ones, I always have to go back to the manual to remember how they're interleaved. Whereas if the parameter names here were upper and lower, like I can just look at the parameter, know how it's going to be represented in the result. I don't need to look at the manual. Which almost makes me wish we would have named the Intel ones on as a parameter.
And so does upper go first or second?
Presumably they should go in the same order as the actual.
Yeah. So left is lower and right is upper.
All right, so then zip low is, we're happy with that then?
I think Levi just suggested we call them odd and even instead of left and right.
I'm not married to that name. I just kind of wish we had done it in Intel now because it made my life easier at least.
Or left is odd.
Left would be even if it's at index 0.
Left is even and right is odd.
So like so not reading the manual, looking only at the method name, if it were zip low with vector even, vector odd, then I would expect even, I would expect in the output at index 0, even sub 0, at index 1, odd sub 0. At index 2, even sub 1, at index 3, odd sub 1, and then so on. Does that sound right?
So your hand motions went from right to left, but your index numbers went from left to right. So which direction do you think that's happening?
Yes.
You intend that even and odd refer to the index in the destination.
Yes.
Which is
left
not exactly
to right?
The related to the argument itself being even. It's not like saying the argument, if calling the argument even doesn't imply only the even elements of the argument are getting used, which might be confusing.
Or I guess what I was getting at is unpack low, even and odd means throw out everything that's in the upper portion of the two input parameters, and then explode each of them individually. Once they're exploded, the odd parameters values will be in the odd indices of the destination. The even parameters values will be in the even indices. That's kind of where I was going with that name, but maybe that's a bit too
using
clever.
You did vector sub 1 and in-memory representation is big Indian?
It's little.
Okay. So using
it shouldn't matter anyway.
Well, but you want the index being the code notation. Because the memory layout versus the code notation changes which way 0 is. Parity flips.
Don't think that's.
I don't like. It depends on what you loaded in and if you dropped to a lower type.
Yeah, I don't think that's it.
Anyway,
but I don't remember offhand. Yes, feel free to blow that argument to smithereens and choose better parameter names. I like high and low in the method name. It makes sense.
Yeah. So these are the ones that are equivalent to unpack low and high.
All right, I just closed it. Was that important?
No, it's not important, but they're the ones that are functionally equivalent to.
So what do I hear now? Should we name them even odd, or should we go back to left, right?
They don't have a strong preference.
I don't have a strong either. If some people think odd and even might be confusing, then left and right are probably the next best.
Yeah. Then let's leave it at left, right for now.
Okay.
and then zip height, basically as proposed, I suppose. I've not checked every parameter type, but it seems to check up.
Yeah. Are these on both 32 and 64-bit, by the way?
No, they're only R64.
No, there's slightly different. The 32-bit has a different version of it because on 32-bit they're destructive.
They're disruptive?
Destructive.
Oh, destructive,
So-
okay.
What does that mean?
So it means essentially it takes just one one of the parameters here would be overwritten. So it's a different operation.
Oh, I see.
I think that's something that we can normalize in the register allocator like we do for x86, though. That just means they're RMW.
Yeah, but effectively, I don't think you should do that because it's better to rewrite your algorithm, taking into account that it's destructive, rather than duplicating the register.
That means we would have to have a ref register if we wanted to have different overloads for 32-bit, and we didn't do that in any of the other ISA.
Yeah.
And historically, it hasn't seemed to be a problem. I don't know. It hasn't been a problem for Intel, at least. I don't know why it would be a problem here, but
Yeah, and on Intel, most instructions until the VEX encoding were RMW, so.
I mean, I guess we could consider that later in the release cycle if it comes down to it, but we should see what falls out. If people are writing code that is low performance because of weird allocator issues. Doesn't ARM have a crazy high number of vector registers?
I don't know if it's crazy high. It's 32.
Okay.
But it's got a fair number.
Okay. More so than x86 has, because I think x86 has, what, 16?
Well, unless you're on AVX 512, and then it's got 32.
Okay.
But then it also has twice the bit width, and the upper and lowers are individually addressable. So.
Oh, good. Okay. Yeah, I'm not too worried then about any refs. We'll let the allocator.
I mean, another option you also have is just not exposing that in one if you think it's bad.
Yeah, but we didn't do that for the SSC. No? And in practice, even on non-AVX systems, we still get really good performance gains from using instructions with same signatures. We didn't special case any of the API stuff.
Yeah, I mean, like I'm just saying, these are the options you have. I mean,
okay.
So what should we do then?
Zip high, I think we said is okay as a zip low.
Yeah.
And then just.
What about the ref thing? And we need to change anything?
I think there should be a follow-up item to see exactly what the behavior of ARM32 is, and then someone should probably talk to Carol since she's the register allocator person, and see what her thoughts are.
And that's for both zip low and zip high?
For probably a lot of the vector functions.
And they're destructive on 32, right? Was that the right?
That was.
Yeah, so on 32, you don't have a zip low and zip high, you just have zip, and both things get calculated at once. The version you want to keep is the one you have to duplicate the register for.
Oh, I see. That's different than it being RMW. Okay, then zip high and zip low should be moved to the ARM64 subclass.
This is all ARM64 subclass right now.
Is it? Okay, I missed that bit.
Right.
So I'm sorry, I got distracted, and remind me what the register allocation issue is for this. This is the issue of whether it should be
There was a slight misunderstanding. When Tamar had initially described it, I had understood it as on ARM32, these were the same instructions, just RMW instead of taking dest and source as separate, but it's actually one instruction that computes both at the same time.
okay. So it's a non-issue. I guess I was.
Is it when it's computing both at the same time, it's writing to a destination register and also destroying one of the input registers, correct?
Mm-hmm.
That seems like a separate API that we should expose anyway for people who want to compute together.
Well, for ARM32, we're not doing any ARM32 work for 5.0, other than just making sure the API surface is consistent, so we can eventually expose it without needing to have a bunch of separate APIs.
Wouldn't that instruction also exist on ARM64 though?
No.
Oh, really? It seems useful.
But you just do two separate calls and you get the same thing.
Okay.
So just to clarify, make sure I got this. This does not produce two.
The ones we're reviewing right now do not. There's a separate one for ARM32 that does, but that's out of scope for 5.0.
Cross that bridge. Okay.
Yeah.
Okay.
Good. I'm done confusing people for the day. Maybe.
Withholding
Until the next
response.
All right, then let's finish transpose even and transpose odd, because then we're done for this issue.
Yeah, so transpose even reads corresponding even numbered vector elements from the two sources starting at 0, places each result into consecutive elements of the result.
Say that again in English.
Once again, there's a good diagram in the manual.
Yeah, well, once again, but this time pasting the diagram.
Result of 0 is left of 0. Result of 1 is right of 0. Result of 2 is left of 2.
Yes.
Okay. So shift,
Well, I think,
take right,
well,
shift it.
there you go.
Huh.
So it functionally performs a transpose.
Yeah, I can visualize.
That's sincere sarcasm. Here, physics.
So this isn't what I understand to be a transpose operation, but okay.
This is a transpose of a 2x2 matrix.
Yes. Okay.
And in these diagrams, which one are they calling 0? Left or the right? Right.
Right.
B in is
N is left
left.
and M is right.
Yeah.
Right, but then when we say even and odd, which one is element? Because
one is even, and
PRN
two
dot
is
one
odd.
is
right, but vector sub 0 is the
on the right side.
is
It's the least significant element, so it's on the right by convention.
But I guess as long as the zeros are consistent with zeros, so it's so here in one is even. Yeah. So right, so it's what I was thinking of. Right.
Yeah.
Take right, shift it by 1, and now and then this one's take. Okay. I don't quite see how it works out to be a transpose, but
Well, or sub matrix. I mean, it's been 15 years. Okay, but So M is left, N is right. So
I'm a bit at loss why.
Oh, M is left, and one is even.
N is left.
Yeah. Okay.
And
Wait.
M is right.
Yes.
what?
Good. That matches my expectation. I mean, I wouldn't call N and M,
I wouldn't call them that,
but in the context of the picture on the left being called even and N being left, I agree.
Well, I guess in both, in the even case, you're only using the even elements of the input. In the odd case, you're only using the odd element.
but they're both inputs.
Right, but it's which one is going down? Which one is effectively being
There we
reindexed?
go.
Left or
Right,
right? And
right,
in both
right,
cases,
right.
right is the one being reindexed.
Well,
Or no,
no.
Left is being read.
left is
No.
It's whichever
in
one.
Even, right is reindexed, and on odd, left is reindexed.
The left,
Yeah.
left is always first. That's what it looks like. Because in destination 0 always comes from left.
Yes.
Yes.
Left always goes to 0 and 2 in this case.
Again, this is probably an instruction that every time you use it, you have to go look at the picture.
For transpose even, the even elements of left are being preserved. In transpose odd, the odd elements of left are being preserved, but they're being they're being moved to the destination.
Yes, I would say
And
the odd
even
elements
elements
of
are from.
the odd elements of right are being preserved, and then you read from left.
That seems fun.
Yeah, I am glad I don't have to write the documentation.
All right, so then means I think we're done with this one. And
That was
so then approve this one, and then because we're still waiting for our friends in interrupt, let me just throw up an issue that I just filed because it only has 2 APIs.
And Tanner, tomorrow just submitted a PR to implement these two. Yeah.
And then next time we have time for our Intrinsics, there's still 32512. And then I think there's still about 40 more Intrinsics that I need to get up onto a proposal, which are variants of shifting for the most part.
Sounds good. All
We
right.
also have 1277.
So what?
We have 1277. Go for the next time, Tanner.
Yes. Okay.
All right, so quick thing on this one. So we want to make more things obsolete. In order to make more things obsolete, we have to solve the problem that people drown in obsolete warnings when we do that. And the mechanism we came up with, or I should say I came up with, is that we introduced the idea of a diagnostic ID that applications of the attribute can use. The idea is that you can share those diagnostic IDs. So for example, you can say, here's let's say 12 types that in a binary formatter, they all get the same ID. And then here's the 14 text that they had, which is basically the namespace qualified name of the rule, right? That's fine, it just gets lengthy, but and the lengthy problem is really mostly a UI problem because in VS there's sure the error code, so if this thing is like that wide, it's going to be a bitch. But
It'll
like,
say this, that.
Exactly. So you only ever see like micro, and then it's like that's not very useful, right? So that's that, and then the second one is the URL format. So like they have this thing in the compiler today or in the IDE when you have an analyzer that actually has a URL set up. The actual ID they show you is a hyperlink. You can click on it. The discoverability of this is super poor, so I felt another issue to add a quick tag to the IDE, so code fixer to the IDE that allows you to just launch the browser. But the idea is that we will have that. I made a URL format because the idea is that you can have one format specifier in it, which basically just gets replaced with the diagnostic ID. So that if you only have to have one URL for your entire library and not have to repeat yourself over and over again, and hope you get it right. Those are the only two APIs you have to add.
Or that's a string dot format valid specifier where 0 is the diagnostic ID.
Yeah, it's basically brace 0 brace, right?
Yep.
That's it. Anybody any concerns with that? Anybody online with concerns? Even the silent, which I treat as wholeheartedly agreeing.
I'd want to see it, I think, actually applied in practice, but short of that seems fine.
So this is you do the existing obsolete you were going to do, and then set these as optional.
Yeah.
Any of the existing things are null unless we.
Yeah, I mean, the other thing is, like, I think if we apply them, I don't think we would specify a message at all, because the message will default to this API has been obsoleted, because we can't localize it.
Right.
And then the idea is that, well, if you want to know why it's local, why it's deprecated and what to do, you have to follow the URL. That's basically the idea, that we don't have to specify every stuff in the error list. Yeah.
This is completely unrelated.
Yeah.
I'm not, but like URL and format and that diagnostic ID almost seem like a tuple that might be useful for other attributes.
Yeah, I mean, like the thing with this attribute is that it's already handled by the compiler. So every time you apply the compiler, it will basically use it to produce a diagnostic. And we don't have many attributes like that in the VCL where the compiler actually generates the diagnostic.
So the only thing I was going to ask is, would make maybe another attribute that can be applied? So if you see obsolete attribute and this other one, that we'll use that, because then you could use that tuple as for other potential URL, like attributes that you may want to adorn a URL with.
But then we'd want the compiler to give would we want it to give you a warning of you seem to have applied a diagnostic ID attribute to a thing that doesn't have an attribute that I understand supports diagnostic ID attribute?
Yeah,
and,
I see. That makes sense.
I think it makes too many error states, and
that's fine.
Yeah,
makes perfect sense.
Good thought. Just
no, that makes that's a fair point.
Yeah, I mean, attributes are relatively cheap. The thing with this one is, one other pushback out from the compiler team is, why don't you make a new attribute and write your own analyzer? And my answer is, you already have that thing, you already handle it, and if I have to write analyzer, then the problem is, well, I better replicate the exact behavior from the compiler, which is not straightforward, right? So, like, that's where that. All right. So now let's look at your two issues, which I thankfully have. Yes.
I would look at the attribute first. I think that's going to be much less contentious.
There's nothing in contentious here.
Does it include a diagnostic ID in the URL format?
No, it does not, but we could add one if you want.
Yeah.
This is, so as it implies, should be a public API. It already is an API. It's just private. We've been using it since, I think it was implemented in 2015. So it's inside the runtime. It's basically just saying that if the method that this is on has this attribute, it is only callable from a non-managed context. And it is not callable from managed. If you try to call it, it will do very bad things.
Oh, it will throw exception. Right? Or,
It's a fail. Yes, it's a fail. It tears down the process. It's not.
But
pretty.
it will be the way we have it coded. It will be diagnosable failure.
Yeah. That's fair.
You don't randomly AV, basically.
Right. We don't randomly AV, but it will. As soon as you try, it will tear it down.
So this is a static method with, let's call it simple inputs and returns that is to be used as a callback from a native context.
And this is calling convention, pretty straightforward. The entry point is, I don't know the history of this, but my assumption is that if you put this on there and you have an AOT compiler, that is the entry point that will be on the native side. That's how it will be projected, so that it can be like get symbol and consumable from a native environment.
Right. I guess as a meta question, why can't it be called from managed code? If you had a thing that took an int and returned an int and was static. That
So
seems-
we can make it work. It just makes the implementation more complex, and there are like corner cases to handle. What if you call it via reflection, for example, right? So now we kind of
okay,
need
so
to do a lot of.
CLR state. And,
But the whole point of this is to make it cheap from native. Like that's the whole. So yes, we as you said, we could do that, but then it's like, well, now you've taken away all the.
Is there no
it-
stub? Is that the idea? There's no reverse stub when calling back from this, when calling back from native code into this?
Yeah, basically, the idea behind this is that like the function pointer you get is directly the function pointer of the JIT function. So there's none of these pre-invoked transition frames.
Does that mean we also can't like use new in these methods?
You can use new.
Because you come back into managed code just fine.
So there's a stub.
No, there's transition, but the transition is inlined in that method.
Okay.
And the reason
So there's a prologue.
Yes,
there is a prologue,
there's
yeah.
a prologue. Yes, there is a prologue.
And the reason why that kind of makes it difficult to make that same method callable from other
It makes
places.
sense now. Okay.
The entry point, we had that entry point. This attribute existed in .NET Native as an internal thing. And for the Corsia original proposal, we didn't have it in there.
I removed it because
because we don't have like this like AOT compiler that can produce native libraries for Corsia today. Right? We might have one in future, but we don't have today. But the Mono team asked for this to be added because their AOT compiler is able to do that, and they do actually plan to use it for iOS and Android.
Is entry point the right name for entry point? Should it be like export name?
It's what we use in DLL import, right?
Yeah, and entry point I think.
And it's nullable because you
It's
can,
optional.
if you don't specify, it's basically the name from the method, right? Similar to the importer.
It'd be,
No, if you don't specify it,
then it's a unlabeled function.
Yeah.
It's just a jump address.
Oh, I see.
So when you print a call stack, it says like, I don't know, we went here and I don't know why.
So I see they note that methods must be marked static, but what is preventing it from working for struct instance methods?
Those structs would have to be. I guess they wouldn't have to be. Is
Right, 'cause
ref considered
The
global?
native code could just pass in a struct pointer as this parameter, as long as they know the calling convention is this call.
Do blittable types include GC tracked pointers or just regular? That's why, because of this parameter would not be a blittable type.
it's like we can relax it. Like maybe we can make it for struct instance methods, right? But basically the way this is designed, it's designed as kind of the minimal building block that kind of gets the job done, right? It's the same reason like why this is not doing any marshalling, right? It's basically this is the low-level building block, no kind of runtime magic on it. Like if we find that the lack of certain type of runtime magic is hurting this a lot, we can always like make it work in more cases.
Then can you do ref int in the signature, or does it have to be int star?
Ref int would be blittable. It would be
No, ref int wouldn't be blittable today. Like ref int is like depends. Like ref int, maybe we can allow it.
I'm just curious.
The in the spirit of the design, we wouldn't allow it initially. We basically still say, hey, this needs to be blittable types only.
So if the callback is giving a keyword star, then you need to say enter uint star, and then you're unsafe and you just deal with that.
Yeah.
Why isn't ref int blittable?
Ref int is GC tracked thing, so anything that's GC tracked isn't blittable, right?
Because it has to have the implicit pinning, right?
It's an int though. There is
Ref int isn't int. Ref int is pointer to int that is tracked by a GC.
And so it has to pin when you cross the p-invoke boundary.
okay.
Sure.
Because it would need to pin the object that contained it.
Oh, okay.
Yeah. Okay. It's fine.
Sure.
Like,
Sure.
it's fine. I'm just thinking through and asking questions
Yeah.
and wondering what all the documentation on this is going to say. And,
Does anybody care whether they're fields or properties? Because in the other attribute, they're also fields. And I mean, I don't care because we can never change them anyway, so we can never do anything interesting in those. So I'm okay with them being fields. I mean, either way, it's probably not a big issue.
Isn't there a guidance that about what should be fields, what should be properties?
like essentially, we say never have public fields.
Yeah,
they're
the
static.
thing with attributes though is because the way attributes are handled is that you can never really have any logic in them because nobody ever calls to them, so they're just read off of metadata usually. So I think for attributes it fundamentally doesn't matter. I mean, I think we generally use properties, but like that's what I'm saying. The attribute, like I probably would have made them properties just because we do this everywhere else, but like just looked it up in there, feels some attribute. I don't care one way or the other.
Yeah, this was, so I literally just exposed it.
Yeah.
So I haven't changed anything. That's just what it was.
Is-
More than willing to change it.
Is there an actual language feature that would come with this to expose load function, the load function pointer, or would you still use?
Oh, so that's part.
That's
This is so if I think the first line is like this is symmetrical for the function pointer, C# function pointers. This is the other side of that.
It's kind of the reason why we want to do it together, so we can test it together, and if there are like any changes required in the C# side, we kind of get it like.
You should see the testing for this. It's a disaster. It's just a mess. Really a huge pain. Who's gonna go back in and fix all
finish
that?
writing the thing that says don't have public fields? Feel inclined to say we should make properties.
attributes generally, or whatever.
Do they? I've always seen everything as get, set, or get. I've never seen.
It depends which.
Apparently, DLL import has fields, so maybe it's things written in 1999 have fields, and things written after that have properties.
Remind me,
So-
remind me what compiler will choose one for you means. It's not just standard call by default, or is it OS specific, or what?
It's basically the default. It's kind of the
System default.
yeah.
Okay, so it's
The same
environment
behavior that
specific then.
DLL import has. I
Yeah,
assume.
it's the same thing. If you don't say calling convention in DLL import, it's the one you will get.
Probably
The
means
one that
it's
more likely will work.
OS.
The calling conventions in practice only matter on Windows x86. No other system really has that situation.
options.
So, yeah.
I can change the phrasing because I try to put as much document on here so that people can. So if there's a suggestion on phrasing,
Yeah,
more than
the
one.
compiler will choose one for it. Might be if omitted. It is the system default.
So this means that field will have value
But it-
calling convention dot z.
I guess the compiler would choose it for you for AOT, but if this is just used from a callback from a non-AOT sometime, it's just a vague system seems better. But
Do you fail if two methods specify the same entry point? Like who fails at that point?
Not that's the AOT compilation side. It's basically we don't. There's nothing to do from the runtime side. I have no idea.
the if you specified entry point and the JIT does it, is it labeling the function or is it?
I don't think
No,
that's
the entry point is really just for the AOT. It's like it's equivalent to what you use DL export in C++ for.
Okay, so in if it's JIT, this value is never.
It's not read. It's
Right.
not looked
Yeah.
at. It's not consumed.
Does it belong on a different attribute, perhaps?
It's
I mean, it does kind of go hand in hand though with maybe
Yeah.
callable.
Yeah, I think it would just be documentation that
Yeah.
says it only matters for AOT.
Okay.
Or we could call it, AOT export name. Again, like just being very clear what it is and that you generally don't care about it.
It should not go on delegates then. Like how do C# represent function pointers at the end?
as a pointer. Like
There's no type representation for it basically, right?
there will be type representation for it. Like they are working on it, and
That's
it will have
the
type.
function pointers for C#. That's why
And
this is
it
kind
will
of
be-
that's why it's related.
It will be different type from delegate.
I see. But like, what? I guess my question is like, when you have a method that takes one, like, how does it look like? Is it a
It
name
could-
type, or is it just basically like basically a pointer?
You could do it as a pointer, or you could use function pointers when it becomes relevant. And the
Mhm.
function pointers API will have you can specify the calling convention at that point, and then you could fully type it if you wanted to, or you can just pass it around as an input.
Have you ever seen? Have you ever used function pointers in C?
Yeah, I guess my question is like, what is the IL syntax for that? Because we don't have an IL type function pointer. So
No, IL
There is an IL type for function pointer.
and always has been. It's one of those features that were available only from IL or from C++.
And you can
Maybe
name
C++.
them?
You cannot name them. They are kind of these.
Oh, they're the signature types, basically. Yeah. Okay.
In order to take a function pointer parameter in the C# method, it actually looks similar to taking one in as C. It's kind of a slick syntax.
Yeah, the syntax is going to be fun, but that's
It looks similar to like standard
it's
function
fine.
if you're familiar.
cool. Then that works, right?
This makes sense.
So I like if the entry point thing is only going to matter in AOT, I think the AOT entry point or name. I think it makes
It doesn't necessarily need to be. You can use it with a JIT as long as some build time step will generate kind of the shim DLL that has the unmanaged entry points. So it's basically like you have to have a build time step that will basically look at these attributes, but it can work with just fine. So
How is it different from a DLL export attribute?
there's no DL export attribute.
That's what I'm saying, but like logically, like what would it differ from that? Logically, what that would mean is you have a DLL that is native, eventually AOT, that has a
That would be similar.
Yeah, that's similar concept. DLL export in C++. It's Microsoft specific extension, and it doesn't take a name. Basically, the name is implied, right? So there's like subtle difference, but conceptually, it's very similar thing.
But you can't specify. You can specify export names.
Okay, I don't know.
You can do that. Like, yes, the default is just whatever the name is.
if we made it attribute DLL export, the null name would be use the name it says right here, and otherwise the string is use the string name. But, like I think we could do, or we can leave it on that. I don't have an opinion. I just think it would have been nice to have the opinion about using fields and attributes. Could have updated.
Well, you can always write another iteration. You want to ruin your life next year?
In 10
Write a
years,
book.
In 10 years, maybe we'll change it.
All right.
I also don't expect us to be consistent one way or the other going forward.
Right. So then, anything else, or is that it?
So what I'm hearing is the phrasing and.
Yeah. So this is what I committed in like this.
Oh, okay, got it. You work.
So I removed the XML docs because that's I think a different one that we don't want to review here, but that will be it's basically the names you propose, the shape too.
Okay, cool.
All right, then that's it, and then
That's that one. Okay, this is good. This is a really complex API. There are two different APIs.
Maybe start with why we are doing it.
Sure. So the purpose of this is to give a low-level API for RCW and CCW management in a WinRT environment. That's the whole point of this.
okay.
That's why it came about.
So runtime callable wrapper and
Callable
wrapper, and well, I can expand the acronyms. I'm just going to nod and smile.
Yep, that's what they're for. Right now, the runtime does everything, all baked in. And so the idea is if we had code generators, which is what is being proposed for some of the WinUI work, which is another thing.
Right.
They can code generate everything, and they can handle it. And that would work technically for COM, but for WinRT, there's a lifetime relationship. We need that coordination between whatever external runtime and the CLR.
Right.
And so because of that, we do need to have we need to provide something. And that's what this API is providing, that low-level hook so that we can provide some part of the implementation and some code generator, some third party can provide, let's say 95%. Just one little case that we need to be able to handle. And so expanding that so that it has all of the ability to basically satisfy an RCW or CCW solution was the approach.
Okay.
So this is similar to native callable, a very low level building block.
Right.
And so that's kind of what it comes down. This resulted in two distinct APIs. One is the first one right there. It's a runtime helper. It is we need to allocate a piece of memory that has the lifetime of an associated type. And the example of that is the code generator generates the layouts for their vtables for a type, and they last as long as the type. So instead of them having to manually know how long this memory should last, providing a API that says, I need memory, it's associated with this type, as long as this type's around, this memory is relevant. If this type goes away, memory is clearly no longer interesting. And that aligns with the you have created a object that you are going to pass to native. Well, that object is clearly relevant as long as types in the runtime back it, and vice versa.
This is associated with the type, so it's like a static field association and not with instances of the type, which is per instance.
Yeah, it is back to the type itself. Yes.
Okay.
And this API, this concept has already existed. It's calling an existing mechanism that already exists in the runtime. It's just now.
I'm just making sure that when we say type unload, we mean type unload and not type instance.
Right, and that's exactly why. As soon as that type goes away, this memory is no longer relevant because clearly nothing is outstanding that is associated with it.
Okay, that so far I think that one makes sense to me so far.
For the type to go away, there must be no instances of that type.
Yes, there must be no instances, and there's no instances of the assembly. Like it's the whole.
Sure.
It's had.
So the dynamic assembly is just dead at that point.
It's actually not. It doesn't have to be dynamic assembly. Right? We have collectible types.
Yes,
even
yes,
for
okay, yes, you're right.
But that is the memory that it's using.
Okay.
Yes. Okay.
So
So
we thought int is enough.
I'm sorry.
Int is enough presumably for the size you want to.
Yeah.
Right?
Yes.
Yep.
There was some feedback about using a uint. That doesn't make it CLS compliant. That's just something that I understand is important, or maybe not.
Some of our other allocators do measure size rather than.
I was going to ask, should it be in and to just go ahead and be long, and if you're on a smaller system, then obviously your long is out of the allocatable range.
Like Marshall.allocate global, for instance, takes int pointer CB.
Oh, really?
One of the
It has
sounds.
But
multiple
I mean,
overall.
honestly,
Wow.
does somebody really need to associate a
One
terabyte
static?
like
It's
Yeah.
whatever.
if they need to call it multiple times to like let them call it 2 to the 32 times to pass the
Yeah,
64.
it kind of in PTR makes sense for APIs that are used to allocate buffers, right? This one is not meant for allocating buffers. It's just
I'm
control
tracking data.
structures.
Right? Yeah.
Okay. So how this works?
You look at code first, maybe.
Yeah. So we can go down. So there's an example at the bottom of some usage. Okay. iPrint is the classic type of COM interface. Print implements it. IUnknown vtable with the QI add ref release. That represents basically the runtime side of things. The iPrint vtable, VF table, if you scroll down, this is the sorry, which direction? This is going to be the RCW side of things, where we oh no, sorry. This is the CCW. This is what is going to be called into dispatch to the managed object. Okay.
This means COM calling back into.
Yeah, exactly. You want to expose some sort of managed object to the COM world. Here it is. Dispatch to it, and it's going to follow the IUnknown kind of. That's the. And so this is the buildup. This is all the stuff that the third-party code generator would handle.
Okay.
So definitely not terrible. Or at least we don't have to deal with it. So if you keep scrolling down, and then so this is the RCW side, the iExternal object. This is kind of the same kind of idea. You lay out your QI, you lay out your associated tables for that object. You type everything in the world, and then if the iExternal object constructor takes an int pointer, and that's from the native side. Okay. Now, the Marshall pointer to struct, that is not what we would advise to do. That is for simplicity of this. Those are optimizations that can be done. Those are very slow APIs. Sure. There are other ways of doing it, but that's the general gist of what would go on. And this is the classic way of rolling your own CCW, RCW, those two objects. So if you keep scrolling down, this is just building up all of the, okay. So now, COM wrappers is the actual API that we're proposing. That was all boilerplate to make it make sense. Okay. Okay, that's what I'm saying. This is a non-trivial API. So the COM wrappers basically represents a collection of APIs that allows you to manage creation of these and participate in some sort of lifetime management. Okay. Excuse me, object identity is also very important. Right. So that's another promise that the runtime uses of sort of identity. And so in order to do that, if the user is interested in that, we need to have a bit more robustness. Now, obviously, just to call out, users, third-party generators could accomplish this, but it's far more expensive for them to deal with it. And so that was another part of this. The providing of a simple object identity promise, as well as participating in this lifetime management. Those are the two kind of things that we're associating. So let's say that we are going to create a COM callable wrapper. So we have a manage object we're going to send down to them. They're going to give me the manage object and basically going to say, give me a int pointer that I would pass down. One of those steps is there already a CCW associated with this manage object? Now, if there is, we've promised the object at any, we'll give you the same one, because you've already called it once. If it hasn't, we call back into this their implementation of COM wrappers, and that's why this is a protected one, and say, here's the object, give me the vtables for this. And if you right there, if you see runtime helpers allocate type associated memory, ideally this would only be done once, right? They would cache this. There's no reason to do this every time. It's not interesting, because a vtable for this object of this type is the same.
Is this two vtables per object or per type?
This would be per so this would be called for this particular object. How that's implemented would be ideally at the type. If object comes through and it's foo, they have some lookup table, they magically do it here.
But the base class that you're proposing would call this virtual method for every unique managed object instance that it has not.
Yes, and it's up to the implementer to do whatever they build up, whatever they want. Yeah, this is a naive implementation.
Right. So I'm just trying to understand the flow.
Absolutely. This is,
so what does allocate type associated memory do when you call it multiple times?
It's like stack allocate. Right, like you're just chaining this allocation onto unload, like a linked list of unload operations.
Associated with that type, yes.
Yeah.
Yes, it's
Eventually, they'll all get destroyed together.
But that's part of the, like, if it's associated with the type, like, if it should be only allocated once, how do they know when to release it? And so that's what using loader allocator would address. Again, the actual implementation here is very naive. It's not great. There are a few APIs in this that are interesting. The example of associate type. This is the canonical example. The other one is you get I unknown impl. This has to do with the ability that a external runtime that's not associated runtime may not necessarily, or maybe want to do something, particularly around lifetime, when the GC is occurring, right? Which means they can't implement I unknown in some instances. So we need to be able to provide that, and so that's what that's for. It's just a static it's a protected static on this COM wrappers. That implementers of it, they have something interesting, and they say, I need the I unknown implementation, and we just send up 3 pointers. Use these in your vtable if you will. Again, building block. So it's really like, yes, this is. So this is, and so once this entry gets, these vtables get created, they get associated with the CCW. We allocate some more memory and some native memory, and then if you look up, if you go back up to the API, which I don't have a call on this, it's basically keep going up to the actual API. I think it's get or create. Create object. No, not create object. That's the compute vtables. If you scroll up, get or create COM interface for object. You've passed in the object, passed in some flags, and the result is going to be an int pointer. Now, whether that's an already existing int pointer, or whether I had to create, or whether we had to create a new one because there's no associated with it, that's what that represents. So it's get or create. Get already associated, or I have to compute vtables and do all this other stuff.
Two things. One, we're out of time. Two, I'm confused by the notion that it's object instance and then the parameter description says it's a GC handle.
Sorry, oh shoot, did I not update that? Sorry.
Okay.
Sorry.
So at one point it was GC handle, and now
we had that was
okay.
Yes. We've got. There's been a lot of. I've tried to keep this updated.
I was making sure it wasn't that it needs specifically a box GC handle.
Absolutely not. That is a very bad. Sorry, that is bad.
So how? Yeah, I guess I'm slightly confused by what this does, because it sounds like your code generator is basically building that representation. But I'm confused how this can return you that.
Because this will optionally call, if you scroll down, the compute vtable.
This is the public non-virtual.
Right. That's public. That's public. So I tried to simplify it to basically.
I see what you're saying. Okay. No, that makes more sense to me. Okay.
The pattern is like this: public method that does first thing it does, it kind of looks up it in the internal hash tables, and if it haven't seen that one yet,
then it
calls back into the code generator provided method.
That one, no, I get it. I thought this was a static method. That was.
Oh no, sorry.
So like,
Yep.
Oh, that work? Okay.
There's some boilerplate along this, particularly the one above that struct above it. If you scroll up, this. Oh, sorry. Scroll down.
The nested struct.
The nested struct. Yeah.
This one here.
This represents the contract to call back into the object that you've created, because we have to lay out what we would call a dispatch table, basically this pointer and how do I get to it.
Right.
Yeah, not terribly interesting. You can see uses. You would use that part when you built up your CCW.
Mm-hmm.
When we just hand back an int pointer, how do you get at the actual object? That assistance with that.
What is this guy here?
That is that object. That's the int pointer that gets passed through. So if you scroll down to the actual implementation, to actually the example, well, right there. So this is the CCW sub. So basically we're dispatching back into the dispatcher, and I need to get back my managed instance. Because the native has called it, I have to hand back a pointer, and that pointer, from this pointer, how do I get to the managed object?
It's a complicated API.
It's a very complicated API. It's a very complicated API. And that's just the first step.
I think that there's enough state loaded in now that with like 10 minutes we could get through the thing.
I don't know. Like I get the scenarios for it.
Yeah, I think in general it makes sense. This is
There's a well, that's the
the-
one part. There's a second part.
Oh, okay.
which is
The RCW side.
Yeah.
Yes.
There are a few questions, that we kind of discussed whether that converters base class it's abstract, whether it makes sense to make it abstract or whether it should have like some, busy dummy implementations of those callbacks that kind of do nothing.
Probably being abstract and making the things that you need to implement abstract is the easiest answer because we're still struggling with other things we've added of like, this is virtual. If you don't overwrite it, your type doesn't work.
Okay, so that's all right. Great segue. There is one API on here that I have. It's basically the object destruction. Because there is a point when we need to say detach this object, and we didn't implement it, so we can't really detach it. We have no insight into it. And right now, that callback is protected virtual. I've implemented it so that you don't have to implement it, but it throws not implemented exception by default.
Yeah.
Okay.
What?
Yeah. If nobody ever calls into your CCWs to say detach, then it's not a big deal. But if someone decides to say detach this CCW or detach this RCW, I can't detach for it.
This isn't automatically called as part of unknown release.
No.
Okay.
No.
What does it mean to return not supported from release?
No. This is the lifetime of the associated native side. It hasn't gone to 0 or it hasn't been GC'd. I want to detach.
If you think of this as an optional feature, then not implemented would be the wrong thing to throw. You would basically say not supported, and then you would make it virtual and say somebody can't provide the feature for this object. If you think everybody has to do it, then just make it abstract. So it kind of depends on what you think the use case is.
That's a fair point.
It's like similar to how streams work, right? Like you can be seekable or readable or writable or all combinations thereof, and you just override the things you want to do. And you usually have capability APIs as well, where you can ask upfront whether this is supported, so you don't have to call the method and then blow up. But like, I mean, in your case, I don't know whether the general expectation is that that's an implied contract anyway, and it really isn't any other way of doing it. Like, if there's nothing you can do in the else but throw, then you might as well not ask and just call the API.
And the thing that I'm having trouble wrapping my mind around is like traditionally the runtime handles things like add ref and release for you.
Right.
And I'm trying to figure out how much of that infrastructure still exists once this.
But this is this is a complete parallel implement. There is nothing associated with that.
But if I were to do this, like I am responsible for add ref and release myself.
Yes.
Okay.
What I'm wondering is, like, I mean, maybe I don't have enough fantasy, but like, how many ways are there to do that? Like, is there only one way of doing it, or like, is there the expectation that different memory layouts can do? I guess it's. I mean, COM is effectively an ABI spec, right? Mm-hmm. So like, how many ways do you actually have to implement that?
I can imagine a few ways. Like the easier way is probably to just keep a GC handle that's not killed until the release count goes to 0. But maybe you have an object pool where your release is, just add me back to the pool or something like that. Like I can imagine that's one of the scenarios that you have perhaps.
The reason why, like one of the top reasons why we are doing it this way is because it needs to. The way the WinUI interop was designed, the XAML GC interops with .NET GC. It's like if you have cycle between do that whole thing, those two GC will cooperate, and it's very hard to do this, replicate this cooperation like outside the runtime, right?
Right.
So that's
and that call is actually done during a GC.
Right.
So if they were going to do this, either they have to provide managed native code, or we have to open Pandora's box of saying, well, you have to write managed code that can run during a GC. And so that was basically the only choices. And so that's I want to Leo, I want to call back something. we do handle add ref and release. If they, if in our implementation of add ref and release, we do that ref counting.
Okay.
That is true. The destroy concept is I want to sever, or what we would normally call in the runtime now neuter, being like you have an RCW, you have a CCW, but the other side has been removed. That's what that means. Sever this connection in a non-natural way. And again, they don't have to use this. They can implement their own QI. But remember, if anybody can call into it and it needs to be executed on a GC, it won't run. Or you'll deadlock the system.
Okay. I mean, that is still a lot of mechanical buzz. So, I don't like, I mean, to me, like, I would have to probably see the source code a little bit longer and actually stare at it and see how these things compose. But I think the general thing makes sense to me.
I want to point out one thing that along with the throwing not supported, which it sounds like that's a no-no. I should do it abstract or make it silent. I get it. So that's great feedback. This one right here. There was another question about this.
Get or create or add
or use. Yeah.
So what's the purpose of the wrapper?
The wrapper is the RCW.
Okay.
And so if that is non-null, you've already basically given me the object instead of me calling create object.
So normally when you get an object back as an RCW, normally you would need to cast it to an interface that is the COM interface you want to call. Yep. And the runtime is still handling all of the QI plumbing under the covers for that?
We are dispatching to those vtables because we asked for those vtables. That's what's going on there.
But that will all work. That's why you don't need to take like a T here and then do the equivalent of an unsafe app.
Yes, right.
Some interface.
Right.
Okay.
So how would I have gotten that wrapper in the first place? I called you before with passing a null, or I already have one from...
this has to do with some constructor calls. I haven't fully gotten... Every time it's explained to me, it makes perfect sense, but I can't remember all of this.
It's like when you... The scenario is like you have both the unmanaged thing and you already created through other means the managed thing, and you just want to associate them together in the system.
So is the idea if I pass you in the wrapper, like you add it to your internal table, so next time I ask you, give me back the same wrapper, even if I gave you null?
Yes, because that would be the same. It's the same. Like, just give me the associated one. It's really, should I call the create object, or should I just use or can you already supply one? The downside to this API, or the downside to this case, is it is kind of degenerate in the sense that if I have that object, I'm going to return you one that's already associated with that external COM object. So you've wasted your allocation. So this doesn't happen very often, but in the cases that it does, there is no real good way of solving the problem. The alternative, the obvious alternative is get or register the wrapper. And so it's so there's another API. So you have get or create. The create instance will call the protected. Another API that says get or register object for COM instance. It doesn't take a nullable object. It just takes an object. And it will that other API will never call create object. That's kind of the alternative to this.
Or you just have an associate.
But what if there's already one associated with it?
You return false.
Okay, yeah, absolutely can do that.
If you want to know whether it was or not.
That's fair.
I mean, we have patterns like that. I mean, like you could also call it like try associate or something that returns false when it can't or something.
Okay.
It seems like the more logical way, because I mean, the describe the error conditions of this and like what happens when becomes a bit more involved. But I mean, to be honest, I'm not super concerned because these are not the kind of APIs people call like a lot, I would hope. So
I can think of literally 2 people that are going to be calling these APIs.
So I would not overthink that too much. Release objects. You just pass in a bunch of objects, and then you release them all.
That's the you want to sever them, and so release objects is probably not the best way. Neuter objects. There was an internal term that we used.
like separate how people use it versus, because it sounds like the consumer and the implementer are going to be different in this case.
Not sort of.
Yeah, not really, because the code generation side would use that to build the handshake.
Basically, this is not an exchange type. This is
Right.
bigger internal.
But then who? So if so the code generator is implementing this, but who's actually calling these public APIs?
That implementation that generated all the generated code that they have for those RCWs is using this to construct those RCWs and interact with the runtime in a controlled manner.
I guess why is there a distinction between public and protected then? If the person who implements it is also consuming, like, why couldn't everything be public or everything be protected, for instance? It sounds like you are trying to draw a distinction between who implements and who consumes, but I'm now not clear on what that distinction is.
Error cases. I don't want to deal with, like, why are you, if you call that, how? Yeah, I mean that's fair. That's a fair point. It's exposing exposing APIs that you should never call this. We'll call this on your behalf for you.
We being the runtime.
We being the runtime.
I guess the one thing I am not seeing is, like, how do you hook these guys up? Like, if you generate this for, let's say, some WinUI component, right? Like, how is this derived type ever registered in the system? How is this being used?
Oh, they would be that. Okay, so this instance would probably be, let's say, a static on some sort of CFU, like concrete implementation.
Right.
And that version of COM wrappers would be coupled with that version of CFU in some way. And so when you generated the RCWs or whatever, you would use that one. It would be private. It would be private to that version.
So the generator basically will create the corresponding fields, new them up at the appropriate place,
Yes,
and
exactly.
that ownership is completely on this.
Yeah, so it's, Levi's point, yes. This is all theirs. They could call this in very, very weird ways. I was trying to be prescriptive about.
Yeah.
The allocate type associated memory, what are the permissions on those pages? Read write? Read execute?
Read write.
Read write, yeah, I don't think there's execute.
The reason I asked is there a scenario where someone would want to do that and then put their own stubs?
Great question.
Because if they do want to do that, those pages have to be executed.
Absolutely. I don't, in this scenario, the idea is to push as much executable code into managed. So I can't imagine, like, yes, you're right. They could.
I didn't know that was a legitimate scenario.
That's fair, but no, that is not a legitimate. The entire point of here is you as a code generator for CCWs or RCWs have to write zero native code. We will write the minimal amount of native code for you, write everything in managed.
So I can imagine then that some of these pointers actually point back into methods that I've implemented using the native callable attribute.
Exactly.
Yeah. What you see in the example, right, is like get delegate or get function
if you
for
scroll down.
delegate, right? So those things would be actually like native callable methods and just taking pointers.
Sure. So we would use a function pointer syntax when it comes online and so.
Yeah.
Yeah, you can implement all of this without those features, but you get a bunch back if we.
No, it's all becoming clear.
Sorry, maybe that was a better approach of explaining it.
It's all good.
Yeah.
I'm like, I see.
Yeah.
I tried to make them separate because they functionally are separate.
No, it makes sense.
Yeah. So do you have any concerns about the APIs? Because I don't have. Like, it seems sensible, but I also don't have a good.
The thing is, like, given the target audience for this isn't normally something that we would spend that much time reviewing. Just saying, like, look, it fulfills a scenario, and we'll have to.
Yeah, I mean, that's what I'm saying. Like, to me, like, these APIs will not be used by mainline people.
So do we? It's like I just noticed there's vtable in one place, and the other place has vt something. Would those be same names?
These guys here?
Yeah. Oh, sure.
Probably.
Yes, I will make this consistent and remove the GC handles. Yep.
I think the API surface looks fine, but after it's approved, I'd want to see some existing open source libraries try and use it. And for example, one of the many DirectX wrappers, and see how it actually works for them, and maybe have a small write-up and see what they say the shortcomings or benefits of it was.
Yep. So that's great feedback. So Jeremy owns SharpGen Tools.
Yeah.
Yep.
That is the external person. I've worked very closely with the WinRT people because they're literally doing this. It's CS1RT, which is a similar thing to SharpGen Tools, but it's targeted purely at the WinUI scenarios.
Right.
And Jeremy's mostly been the go-between between those two, primarily because he has a tool that he owns that he writes this. And so I have received a lot of feedback from him on this. And yes, a plan is I have bribing him with something that once this is public, or at least in a preview, that he can go update SharpGen Tools and say, does this really satisfy a real scenario?
Yeah.
I mean, there's
Well,
nothing.
and then I also work on the Clang Sharp pinbook generator.
Okay.
And I've got my own DirectX bindings that are separate from SharpGen,
Okay.
which just uses raw function pointers, so I might try it out as well.
That'd be great.
I had a scenario for this too back in like 2013.
Yeah,
I wish you could go back in time and do this today.
Right, but I guess I think that's the point of where we're all getting at. There's like going to be 5 people worldwide that are going to use this.
Yeah.
I like the feedback about I will change and not implement it. That's fair. I'll make that abstract. It sounds like that's the preferable approach. That's a fair statement.
Yeah, make that.
And also, it sounds like the try register is the preferable approach here.
Yeah.
Okay. I will do that.
Yeah, and also nothing in here seems to be even NT specific, right? This is all generic for COM, right? So it should work for any COM object.
Yeah, yes, there's other, okay, so one last thing, I guess. The implementation of this is actually unrelated to Windows and everything. There's nothing in here that's using any Windows. So right now, this is only supported on Windows, but there's literally no reason that we can't flip the feature flag and say this is everything.
That makes sense.
Does Unix have any notion of COM?
They don't, but this.
So Unix doesn't have COM, but the system B ABI, the actual function or the B table layout is identical to COM. So
Right, because it's just C++, right? Yeah.
So they could use this. We have had with MS Jabby. I think he's one of the Bing people.
Yeah.
He's actually said this would be really cool. I think there's 1 or 2 thumbs up on that. If this is cross-plat, there is nothing stopping us from doing it. That's not a priority right now, but it was designed around COM ABI.
Sure. I mean, at its core, COM is just a series of interfaces and lifetime in OS. There's nothing tied to the OS.
Right. Basically, the thing that's kind of tied to the OS are the marshalling generators, right? They are kind of OS tend to be OS specific,
Yeah,
and it kind of decouples.
Yeah, I mean, I don't see any red flags. I mean, it's an interval API, so it's not going to be pretty no matter what we do. That's fine. Like when Jamie brings his crazy crypto APIs, it's like, well, yeah, it is what it is.
As a side question, so there's an API here to allocate memory associated, right? Is there potential for an API that associates arbitrary data with a type? Like if, say for instance, that we wanted to, one of the scenarios that comes up pretty commonly is I want a cache of something where the key on the cache is a type, but I'm afraid of making my own static class and then using type as a key because now that type is rooted. It can never be unloaded ever.
Oh, sure.
Would something like this work around that? If you had like an arbitrary cache as opposed, in addition to just this? That way, if the type goes away, like I'm not rooting it inside of my system.json global cache, for instance.
The API for that today is conditional weak table, right?
Yes.
It's not ideal, but that's the API we have today.
Yes, but I think things never get removed. Maybe that's
No, conditional vtable, it doesn't keep things alive, right?
right, but it doesn't ever prune though. Like
does
don't we
prune,
just
like
end up with dead
one-
entries on it?
So basically, if you make conditional vtable where key is the type
Right.
and the value is your arbitrary data, that entry doesn't keep that type alive.
Right.
And once that type gets garbage collected, that entry will go away.
Okay, that part I didn't realize. I
Yeah.
thought the entry was just marked dead and that the space could never be reclaimed. But, okay.
So it kind of has like resizing policy. So initially the place gets marked as dead, but once new things come in, it will get replaced with.
So
like,
there is like an auto pruning, pruning like mechanism.
There's it's a better thing. Like oftentimes you actually want these things as caches. You don't necessarily care that it kind of lives as long as the type. You really care about, hey, this is kind of expensive to create.
Yes.
That's this API that we don't have that I would love somebody to pick a button to design.
That you don't think something like this would be the right place to put?
I'm not sure what the shape of that API would be, but like, those APIs typically are, like key value collections, right?
Yeah,
so
you're right, they are.
Sorry, what is the type that you want? What is the API that you would want?
cache.
And how is that different from the conditional weak table? What is the
So conditional leave table keeps things alive forever, right?
Well, no, conditional weak
no.
table does not.
But
a regular static dictionary does.
Yeah, but like imagine like you have regular expressions today. You have like cache for regular expressions, right? That thing is some completely ad hoc policy. If like let's cache last 100 and and it kind of when it's more, it kind of gets pruned, right?
But there are lots of scenarios where people just new up a regex and then pass a literal string in there. That literal string instance is going to be the same every single time.
Yeah.
So we could use referential equality on that string to do a fast cache. Okay.
All right. So then that's it.
Yeah, I didn't mean to distract from this. I just realized it's a somewhat related problem to this API.